rotational motion is possible for the rigid bodies only. That means now our chapter is restricted to rigid bodies. We are not going to deal with fluids, that is liquid and gases. Even if solid is there like a sponge type, then also that's not going to be the topic of our discussion. Only rigid bodies. What are the rigid bodies? You apply the force, external force on the rigid body. The internal arrangement or the relative arrangement of the constituents will not be affected. With the rigid bodies, three types of motions are possible: translatory, rotational, and when you combine them, it becomes the rolling motion. So we'll come across all the three types separately. In between, we'll be having a very interesting and specific case of precisional motion also. Translatory term is not going to be used for a particle. For rigid bodies only, translatory term will be used. If the body is being moved in such a manner that all the particles are having the same velocity, we call it translatory motion. For example, here this gentleman is pushing this block, big block. When this big block moves on the surface, all the particles will be having the same velocity. When I say same, means they are having same magnitude and same direction as well. Second type of motion that we call rotational motion. This motion generally takes place around some axis, and in this type of motion, all the particles of the rigid body will be completing circular motion in such a manner that circle will be executed by all the particles and their centers would lie on one particular line that will be termed in future now as axis of rotation. Remember, rotation is always defined in terms of axis of rotation. So rotational quantities are also based on the axis of rotation. For example, moment of inertia about tangent will be different. Moment of inertia about the diameter will be different. So we have to be careful. In this chapter, whenever we talk about rotational quantities, the axis of rotation must be noted, clear, or specified. If you are talking rotation without axis of rotation, it's like somebody is asking the fare of from some booking clerk and he is not telling where to go. Unless the destination is told, how that booking clerk will tell you the fare of that city. Similarly, axis of rotation must be clear. Now, the third type of motion is axis of rotation also rotates. See, this is axis of rotation, something is rotating. But this way means the axis is also rotating. You bring the picture of a spinning top. That is best example of this precisional motion. You would say that in this type, the axis of rotation also rotates about some given axis. And finally, the most interesting that actually we are aiming at by doing all this, rolling motion. Rolling motion, you might say, simple mathematics, it's a combination of translatory and rotatory motion as well. For finding any quantity regarding rolling, you have to find the quantities for translatory and rotational and then you sum up. I'll quote one very interesting classical example. You are looking at this bicycle. This is the old design, old fashioned. It is having the stand which used to be both sided. This is at rest, resting on this stand, classical type. In this case, if somebody just pushes the pedals of this bicycle, the wheels, rear wheels will start rotating. It becomes a clear-cut example of rotation. Now, I apply the brake of both the sides here. In this handle, I apply the brake. and we alight it from the stand, we push it forward because the wheels are not having the liberty to roll, to rotate, because you have applied the brake and you pushing. Then what does it mean? Simply the wheels will slide. And this is going to be the case of translatory motion, in which only the wheels are sliding. You leave the brake, you make them free. Now push the cycle forward. What will happen? The wheels will start rotating also, and the whole process will now be termed as rolling. Rolling is a combination of translatory motion and rotational motion.